I have a differential equation du dv equals to uv times sine of v squared. I would like to find a general solution first and then plug in the initial condition to the general solution to find the particular solution. Du over dv, that means we are looking for the derivative of u with respect to v. Since this is about separation of variable, I would like to put the v on the right hand side by just multiply both sides by dv. So after you multiply both sides by dv, the dv will be on the right hand side. So you have du equals to uv times sine of v squared and then dv. So to put the u on the left hand side, just divide both sides by u. So we have 1 over u du equals to v times sine of v squared, so dv. So now the separation of variable is done. So let's mark this. So these two lines, they are called separation of variables. And then I have all the u's on the left, all the v's on the right. The next step is we will have to integrate both sides. So let's do the color coding a little bit. So for the integration, I will just do that in blue. So on the left hand side, the integral of 1 over u is just ln absolute value of u. So ln absolute value of u. And then the other side, you have to use a u substitution, but the variable u is used. So let's use another letter. Let's use a w. So let's use w equals to v squared, and then dw is equals to 2v dv, and then 1 divided by 2v dw is equals to dv, and then this is for change of variable. I am going to replace the dv with 1 over 2v dw. So let's do the change of variable. We have integral v and then times sine of w, and then the dv is 1 over 2v dw. And then very easy, you can get rid of the v right after the change of variable. And then this is, you take the 1/2 out, the integral of sine is just a negative cosine. Ln absolute value of u, you bring the 1/2 out, the integral of sine is equals to cosine. I know I missed a negative, so the integral of sine is negative cosine, so there is a negative in front of the negative 1/2, and then you add a c to it. And then the integration is done. How do you put this to, I should say, how do you take the u out of the ln? At this point, this line is in exponential form because the u is in the ln. To take the u out of the ln, you have to mention that the base of ln is e. So to put this back to exponential form, you have to take the base e as the base and then raise to the entire rest. The entire right hand side is now in the exponent. So negative 1/2 cosine w and then plus c. And then what about the left hand side? The left hand side is just u. And then this one, I have to remind you the properties of exponents. So let's say you have x to the n times x to the m. Same base, you have x to the m plus m. Let's say e to the n times e to the m. So that is e to the n plus m. So you have the e, you have a plus. So that means you have u equals to, so you have a u equals to e to the negative 1/2 cosine w. Oh, by the way, the w, you have to put that back to a v square, right? So since w is equals to v square, so let me do this correction a little bit. So the w is now v square. So you have a cosine v square and then times e to the c. And then the e to the c is just a constant. So this one, the e to the c right here is just a constant. I always call this a big C. So you have e raised to some power times a very big C. So at the end of the day, u is equals to a big C, and then times e to the negative 1/2 cosine v squared. And then this is my general solution. So since e is not evaluated yet, you call this general solution. So general solution, and then now we go back to the initial condition. So where u of 0 is equals to 1, usually the book write the initial condition or initial value like that. U of 0 is equals to 1. That means when v is equals to 0, u is equals to 1. You plug in v, plug in u, and then you solve for c. So u is equals to 1, and then spec c, e negative 1/2 cosine 0 power is equals to 0, and then cosine of 0 is equals to 1, so e negative 1/2 times 1, and then you divide both sides by the e, so c is equals to 1 divided by e to the negative 1/2. So this is a negative exponent, right? So to get rid of the negative exponent, all you have to do is you put the entire term back to the top. That means you do a reciprocal. So e is equals to e to the past 1/2, and this is your constant. And then now let's write the particular solution. So you have u equals to e to the 1/2 times e to the negative 1/2 cosine v square. So the same base multiply, that means you add the top. So you have u equals to e to the negative 1/2 cosine of v square. So just add a 1/2 to the end, and then this is my particular solution. Depending on the preference of your teacher, basically both forms are acceptable. If you are doing homework online, I'm sure they want you to put the 1/2. They want you to merge two e's together, and then this is called particular solution of the general solution in that initial condition. Alright, so that is the end of this video. If you think my instruction is helpful and clear, share the video for me, click the like. If you're on your way out, click the subscribe. Appreciate for your support. I will catch you all in the next lesson. Signing out.